Today we're going to talk about one application of matrices, which is to solve systems of equations. This is a practical application because a lot of times in life, when somebody's trying to solve a problem, a linear equation will work for that. I mean, when we think about a distance, rate, time type situation, that's a linear situation, or a lot of times we can make cost equations that are going to end up being linear. But often there's more than one restriction going on, and so that we have two or more equations that we need to be satisfying at the same time, which is what a system of equations is. So matrices can simplify the process of solving a system of equations. So you learned how to solve systems of equations, first starting in Algebra 1, then we do it again in Algebra 2. If you took pre-calc, we do it again there. So it's something that you have seen at least once or twice, maybe even more than that. But we're going to simplify the process today by allowing the calculator to solve them for us using matrices. But before we do that, I want to show you what the calculator is doing when it's doing the solution. Again, just for this first example where we have two equations. Once we get into having more equations, the process is the same. There's just a lot more steps. So the process then gets messier given a lot more steps. But what the calculator is doing is actually the same.
On our test, are we going to have to know how to
do it by hand? No.
Okay.
No, you'll be doing them all on your calculator. I just don't ever like to give students a graphing calculator and just say, like, here, press these buttons, and have no clue what's happening. Again, I get you to at least see what it's doing, even if you maybe don't totally understand or couldn't necessarily do it yourself, just to not press buttons and have no clue what's happening in the background. So in Algebra 2, and Algebra 1 and maybe in pre-calc, you learn to solve systems using a couple of different methods. One way was called substitution, where we want to try to get one of the letters alone and plug it into another equation. The other method was called either linear combination or elimination. That's what I call it. And that's where what we want to do is multiply one or both of the equations by something so that one of the letters would disappear. So for example, in this problem, and you don't have to write out all of this if you don't want to, but you can, I would multiply this equation by a -2, and that would turn it into a -2x plus 2y and -8. And then if I add those equations together, the x's disappear. I get 5y equals -25, which allows me to know that y is -5. Which I could then take back to the beginning and plug in and find out what x is. Okay, so x minus -5 equals 4. So I plus subtract 5, and x is -1. So that's how we learned how to solve systems of equations in Algebra 1 and Algebra 2, and if you took pre-calc in there as well. It's actually what Algebra 2 is doing right now. When we work in a matrix, what we're going to do for this is set up a matrix where each column represents a variable or a solution. So my matrix is going to have 2 rows and 3 columns. So the first one's going to be 2, 3, -17, 1, -1, 4. So I write out coefficients, if it's a coefficient of a variable, and then I write out the solutions. Now what we would do with a matrix is very similar in process to what we just did, in that we want to multiply so that something disappears. We want to try to make something into a 0. And again, this is the by hand process. On the calculator, we'll hit a few buttons and it'll spit this final answer out. But what I would do here is I would multiply the second row by -2. That's going to turn it into -2, +2, and -8, which is really what we just did. Right? We did that same exact thing before. Just when I work in a matrix, I get to kind of ignore the variables. And then I'm going to rewrite this matrix, making a replacement that if I add together the top and this answer, I'm going to replace the second row with that. So 0, 5, -25. So I'm going to add together the two things that are circled in blue, and I'm going to make that my new second row. And my top row will just be the same. Now what I want to do is multiply one or both of the rows by something so that that 3 disappears. And so to make that happen, I would need to multiply this one by a -3 and this one by a 5. So 10, 15, I'm going to say -85, but I might be making that up. So
Wait, why do you want to get rid of the 3?
so that that becomes a 0. I want the diagonal, I want to have like an x of zeros. So a diagonal of zeros.
Why?
I'll show you why. So this is -85. And then I multiply this one through. And that's positive 75. Then what I'm going to do is add together those two green rows and replace the top row with it. So it gives me 10, 0, -10. Now if I divide the top row so that I have a 1 here, I would divide by 10, and that would give me -1. And I want to divide the bottom row by 5, so I get a 1 there, and that gives me -5. And that gives us exactly the same solution as before. The solution is these last two numbers over here. So our goal is going to be to have this diagonal of 1s and diagonal of 0s. And then over on the far side, there will be two numbers there, and those two numbers are our answers. Okay? So it's the same type of process that we're multiplying an equation by something and adding it to the other equation. So it's the same type of process that you learned in algebra, just we get to kind of ignore variables when we do matrices. Then do this on the calculator. And what you're going to want to do is set up your matrix. So when I look at the problem, I set it up by taking the coefficients and the solutions. And then we're going to want to type this into the calculator. You're going to be using different matrices tonight than you did in the past, so we can just call this matrix A. We can overwrite what you have as matrix A because you don't need that anymore.
Wait, where did you get those answers that you turned into like a matrix?
I'm using the numbers from the problem. So the coefficients 2, 3, and -17. And then the coefficients 1, -1, and 4.
Oh, so
And
this
the
is still the
equations.
same problem?
Yeah, still the same one. Yep, I was just showing how to do it by hand, and then now we'll look at how we do on the calculator. So I'm going to go in and edit matrix A. It's going to be a 2 by 3. Remember, rows go first, then columns. So I have 2 rows and 3 columns. Then I get, put in my entries. Then what that form is called when it has diagonals of 1s and everything else as 0s is called reduced row echelon form. It's a really fancy name. We just call it RREF. So to make your calculator do that, we're going to go back to the home screen. I can clear out all our stuff from yesterday. And then I'm going to go into that matrix menu, second matrix again, and I'm going to go over to math. And I'm going to scroll down that list until I find something that says RREF. And I'm going to choose that. And then I'm going to tell it that I want it to do that to matrix A. You can close the parentheses or not close the parentheses, doesn't really matter. Hit enter, and it spits out that answer. So our answer goes alphabetically. That X is the first answer, and then Y is the next one. So the solution to this to this system of equations would be X is -1, Y is -5.
How come when we did it by hand we got -3? Or was it just me?
Did I make a mistake when I was doing
Yeah,
something
I
one of
just
the
said it was
times?
We got
-3.
Oh, did I? I made a mistake then on that first
Yeah,
one.
because I was kind of confused. I was like, why did we get
I divided wrong. Yep. Yep, I made a mistake when I did it the first time then. Should get the
There's
same
only
answer no
10
matter how many ways we do it.
I think it was just divided.
So then for the next one, to put that one in, I'm going to go in and go second, matrix. I'm going to just put it in A again because I don't need that one anymore from last time, so I'm going to hit enter. But this one has more. There's 3 variables and 3 equations, So it's going to be a 3 by 4 matrix. So you enter the coefficients and then what's over on the other side of the equals. And then do the same thing for each row.
So what was the first one? 3 by.
It was 2 by 3. The rows are how many equations you have, and then the columns are how many variables, and then one more for that equals side. So for the first one, we had 2 equations, so we needed
there's
2 rows.
Z's. Okay.
This one has a z, so it has a third variable.
I didn't
So we
notice
need
the
one
Z.
more column in there.
Okay.
If you are missing a letter, this is really important. So not always will all of your equations have every single letter. So it could be possible that you have 3 equations and some of them have x, y's, and z's, but maybe one of the equations only has x and y. You have to enter a 0 for that one, okay? So if you're missing one of the letters in one of the equations, it's like it has a coefficient of 0. So you have to have that placeholder of 0 in your matrix then. So then once we get our matrix entered, we can go back to our home screen. And second matrix, really I could just hit enter because since I already redefined A, if I just hit enter, it'll actually redo the exact same thing it just did. But I can go to RREF and choose again matrix A and hit enter. And it gives us our solution that x is 2, y is -1, and z is -2. Not all of your solutions will be whole numbers. So if you get decimal answers, if they're nice decimals, you can just keep that. If they're really messy, you can make the calculator turn them into fractions again, like we learned to yesterday. Yeah?
We try to like x equals this.
Yep. Instead of writing like the whole matrix as the answer, I would just say x equals y equals z equals.
Oh, so
So like this one, I would write the solution just x equals 2, y equals -1, z equals -2.
or if we write out the whole matrix, that's fine.
It's fine. Yep, if you write out the whole thing. It's just more writing. You can actually even write less if you just put them in like parentheses in order. It's an acceptable way to write the solution as well. Alright, so for the last one, we got a word problem. So what we need to do is turn these words into our equations. So you're planning a birthday party for your younger brother at a mini golf course. The cost of admission is $3.50 per adult and $2.25 per child. There's a limit of 20 people, and you have $50 to spend. How many adults and children can you invite? So we're going to pay $3.5 for each adult, and so plus $2.25 for each child. Now this equation is talking about money, so what does that need to equal? Our total amount of money we can spend. Right? So however much I'm spending on adults and however much I'm spending on children, that should be $50 because that's the most money we have to spend on this. Then we're only allowed to have 20 people. So that is our total number of adults and total number of children should be 20. So we have one equation that represents the cost of this event and one equation that represents like the capacity of this event. Okay? So then we can put these in as a matrix. So I'm going to go second. Turn my calculator back on. Go into second matrix and edit this thing. This time I had 2 equations. So it's going to be a 2 by 3. And I had $3.50 adult, $2.25 for a child, 50 total, 1 adult, 1 children, 20 people total. And I can quit out to the home screen. On the last one I said, since the last thing it says is RREFA, and I just renamed A, if I just hit enter, it'll actually calculate it again. I don't even have to go in and choose RREF again. it'll just recalculate it. It's kind of hard to see, but it's just this last part here. So this tells me that I can have 4 adults and 16 kids, which seems like kind of a good party ratio.
Should there be
4
any
adults.
that have decimals in your answer?
On something like this, no, because we want whole numbers of people. If it's just a system of equations, like there's no context to it, then it's fine to have decimals or fractions as answers. But if there's a context to it of like people, we don't want to have portions of people.
Right.
So then we should end up with whole numbered answers.
So you just write $4 and 16 people.
4 adults and 16 children.
Oops.
Okay? All right, that is our last lesson on matrices. So we'll have this lesson today. Then when we return on Monday, we'll review what we've learned about matrices, and then we'll take a test quiz thing on matrices, and then we'll go on to our next topic.